All right, 1.2 multiple choice. 3 of the roots of a polynomial equation of a rational function have rational coefficients -3, 2i, and 4 plus 5 root 6. What is the lowest possible degree of the equation? All right, so we've got -3. That's just 1. 2i. If I have 2i, that means I also have -2i. So now that's 2 more roots. If I have -4 plus 5 root 6, that means I also had -4 minus 5 root 6, because those behave similar to the i's. So that is 1, 2, 3, 4, 5 possible solutions. Let f of x represent a third degree polynomial function with real coefficients. When y equals f of x is graphed, it is found that f of 3 is -1 and f of 4 equals 2. Which of the following must be true? Okay, so let's think about this for a second. So we've got some graph f of x, and we know that when 1, 2, 3, 4, I always draw a picture. So at f of 4, so when x is 4, y is 2. So that point would be there. And when f is, oh no, my pencil is dying. When f is 3, when f of 3 is -1. So that's going to be there. All right, so the function f of s has exactly one real zero on the interval 3 to 4. Well, it has at least one. We know it's going to have to cross through there between 3 and 4. Is it exactly 1? No, because this says it's a third degree polynomial function, and that would be a linear function. Well, I guess it could be. It could be. So it could have exactly 1, but we don't know that, and there's no way to know if it's exactly 1. The function f of x has exactly one real zero on the interval from -1 to 2. No, that is incorrect. We know it's going to cross between 3 and 4. The function f of x has exactly 1 or 3 real zeros in the interval. I like that answer better because it's either 1 or 3. Well, we know it's got at least 1 because it has to cross over, but maybe it does have more than 1. And it can't have 2 because it's a third degree polynomial. So it either has 1 or it has 3. The function f of x has exactly 1 or 2. How do you have exactly 1 or 2? Like that doesn't even make sense. C is the correct answer. C of x represents a fourth degree polynomial function with real coefficients. When c of x is graphed, it is found that c of 5 equals 3 and c of 9 equals 4. Which of the following statements must be true? Okay, it's a fourth degree polynomial. And what this is telling me is I've got 2 points that are above the x-axis, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Why does it have to go all the way to 9? Okay, so 9 and 4 would be like here, and then 5 and 3 would be down here, right? Okay, so it's going up from left to right. That's all we know. The function has an odd number of real zeros. An odd number of real zeros. Well, no, because if it's a fourth degree, they come in pairs. So it either has 2 or 4. So that's out. The next one, it has either no real zeros or an even number of real zeros. Yeah, that we know is definitely true. It has to be an even number because it's either it has none or it has 2 or 4. The function has at least 1. Nope, because it can't have 1. No conclusion is possible. That's not true. We can conclude something. We can conclude B. It's going to have an even number of roots. Why is this page loading? Ah, there we go. Because I had a big picture. No, that's not the page we were on, folks. We were all the way back here doing our multiple choice. There we go. Okay. Based on the accompanying graph of h of x, which of the following statements must be true? Sir, did you need to do that? Oh, where are we now? Sorry, guys. Technology is not always our friend. Please stop jumping. Oh, stop it. I know you're in this section. All right, here we go. The degree of the function is even. No, this looks like an odd function because it's coming in from one direction and leaving the other direction, right? So if it's coming in and going out opposite sides, it's odd. This is an odd function. The leading coefficient of the function is negative. No, because this is an odd function and odds go up from left to right. That's positive, and they would go down if it was negative. But this is going up from left to right, so this is not negative. X equals -2 is a multiplicity 2. So that means it has a bounce. Multiplicity means bounce. So if you need to write that down somewhere, multiplicity equals bounce. And no, this is not a bounce at 2 because it crosses the axis. Two of the factors of the function are x equals -2, or x plus 2 and x minus 4. Yes, that's true. This is x plus 2 and this is x minus 4. So D is the correct answer. Given a non-constant polynomial function whose domain is a to e, where a is less than b, which is less than c, which is less than d. Oh, good God. If f of b equals f of c equals f of d equals 0, and no other values of x in the domain are such that f of x equals 0, which statement must be true? Okay, so if you haven't given up already and you're still paying attention to this problem, like, nice job. Because this is a lot of words and this is a lot of word vomit just to like make you freak out that you don't know what this is. But you can do this, okay? So we know, like, let's say we have a number line, or we'll just draw, like, say this is our x-axis, right? And we have A, B, C, D, E, right? Because they're in that order. And we know that f of B equals 0, so that's a 0. F of C equals 0, that's a 0. And D equals 0. And nothing else. So A and E are not zeros, is what they're telling us. Okay. Which of the following must be true? There is only one relative extrema. Nope, because look, it's going to have to go, like, it's going to go crazy town here. So it could go, this is just theoretically, it could go up like this and then turn around. And then we know it's going to have to cross again, right? It could go like that. Or it could go the other way. It could go like this. So there's a couple options here, but like this is not possible. Not only one extreme. It's going to have at least two. Okay, it's talking about this, the relative min and maxes. There are two relative extrema. Yes, there are two relative extrema. That is true. I'm going to keep reading the answers, make sure that that's the only one that I agree with. F of A is greater than 0. Not necessarily, because it, like, if we look at A here, it could be above A or it could be below A. The dotted line is below. The solid line is above. So it could be either of those, so that's not right. The graph falls on the left and the right. Meaning it goes down on the left and the right. No, it's not going to do both of those. The answer is B. Let f be a polynomial function that is even and continuous on the interval. Uh-oh. What is that supposed to say? I don't know what that's supposed to say. Hang on. What's the interval? What is the interval? The interval -3 to 3. Hopefully yours says that. Okay. The function f has the properties indicated in the table below. All right. Which of the following is f? Okay. So when x is 0, f is 1. That's true on all 4. That's not helpful piece of information. Between 0 and 1, it's positive. So that means it's above the x-axis, which is true for all of these. Okay. At 1, it equals 0. Also true for all of them. Between 1 and 2, it's negative. Yep. Actually, no. D is now out. Because it is not only negative. It's positive from 1 to something here, and then it's negative. So the answer is not D. All right, and then at 2, it's negative 1. That's true, true, true. Okay, from 2 to 3, it's negative. 2, we don't, it looks like it's negative here, but hard to say. It looks like it's negative here. 2 to 3 is also negative there. Okay, so we're between A, B, and C. Now let's go back to what we have. The function is even. Okay, all of these functions are even because they come in and go out in the same direction. On the interval, and continuous on the interval negative 3 to 3. Okay, that just means that the function exists between those numbers. And here's the list of properties. All right, so let's keep looking at this. Since it is a polynomial function, we know that it's going to be a nice smooth curve. B here has these V's. That indicates that there's some kind of absolute value or something happening. So it can't be B. So B is out and D is out. And that leaves us with A and C. I'm just going to erase these marks because I think they're distracting. Okay. So that leaves us with A and C. Further, since it's even, it has to be symmetrical. Okay, so if we see even, that means symmetrical. And A is the only symmetrical graph. So that's why A is the choice. Number 7, for what value of K is x plus 1 a factor of the function? Aha, so there's K right there. All right, so here's what we want to figure out. We know x plus 1 is a factor, right? So that means when I plug it into the equation, I should get out 0. So f of negative 1 should equal 0. So I'm going to go ahead and plug it in for x, and that leaves me with k. So I have negative 1 to the 4th plus 6 times negative 1 to the 3rd plus k times negative 1 squared minus 26 times negative 1 minus 24. So here I get positive 1 plus negative 6 plus k plus 26 minus 24. When I get all of those, and that has to equal 0. And that gives me, let's see, this would be 2. And this is negative 4. 2 plus, is that negative 4? That's negative 5. You ding dong. That's negative 5, and that's 2. So this gives me k plus negative 3 equals 0. So k equals 3. So if k is 3, then this is a factor. Which of the following polynomial function is a possible polynomial function for the graph? All right, so let's see. We've got some negative number here with a multiplicity of at least 2. We've got something else here with a multiplicity. And then we've got this guy, which is just a one-off. So if we look at our numbers, they're giving us options of negative 5, 5, 1, negative 1. So this is definitely a negative bigger number. So like this could be potentially negative 5. And then this could potentially be 1, and that could potentially be 3. Okay, there's not really another way to write this. I think that they're putting these negatives here to confuse you because they want you to think like, oh, it's x minus 5, but you know better that it's not x minus 5. It's going to be x plus 5, and it's going to have a multiplicity, which means it's going to have a power. So it's not this guy, right? And then x minus 1, that would be at the positive 1, also with a multiplicity. And then x minus 3, so this is going to be c. Which of the following statements must be true about the function that is represented in the graph below? The limit as x goes to negative infinity is positive infinity. That is incorrect. The limit as x goes to negative infinity is negative infinity. Down there. So that is incorrect. F of negative x equals f of x. So if that's true, then it would be symmetrical in some way. And it would be an odd function, which this is definitely an odd function. If this were true, then it would be an even function. And then this function has no zeros. That's a lie. All right, so we crossed off both of those. So we're here. Is it an odd function or is it an even function? Well, this function... Whoops, sorry. I wrote that wrong. Oh, good gosh. This is an even function because if you plug in something negative, you're going to get out a positive, right? So that's an even function. And this one's the odd function. All right, there we go. And then if I look at this, this is in fact an odd function because it goes up one side and out the opposite side. It's down and out. So the answer is C. Let G be a polynomial function over the interval a, e with the properties listed in the table below. Which of the following must be true? All right, so this function is increasing, increasing, decreasing, increasing, decreasing. Let's draw a picture. So we've got A, B, C, D, E, F. And from A to B, we're increasing. And then B to C, we're increasing. So we're increasing this whole time. And then we start decreasing. And then we start increasing again. And then we start decreasing. Now, it's polynomial, so it's not actually pointy like those mountains I just made, but you understand. All right, there are two relative extrema. Relative? Well... That's relative. That's a relative min. These would be relative maxes. But they also could just be global. We don't know that they're not global maxes. So I wouldn't... No. There are three relative max extrema. No. I mean, there are, but again, we don't know if these top ones are globals. There are 2 points of inflection. So a point of inflection is where you go like... As you're coming up, you start turning, right? So it's this like middle point when things start turning. There's at least 1, 2, 3, 4 of those. So no, there are 3 points of inflection. Well, actually, you know what? We don't know that this is turning because that could be leaving that way. And this could be leaving. But let's see. Let's go back. The table provides us information. So looking at the points of inflection occur at input values where the rate of change of function changes from increasing to decreasing or decreasing to increasing. Okay, fair enough. So that would be 1 inflection point here, 1 here, and 1 here. Right? So anything where we're changing from an increasing to a decreasing. That would give us 3, so that would be our correct answer.